Hey everyone, and welcome! Today, we are going to crack a code that describes the entire planet. We're talking about the language of climate, and I promise, by the end of this, you'll be totally fluent. So let's dive right in and start decoding.
Just think about it for a second. Our world is just so incredibly diverse. You've got these steaming, humid jungles, then you have bone-dry deserts, and then there are the frozen tundras. So how on earth can we organize all that variety into one single system that actually makes sense? Well, that is the exact problem we are going to solve today.
Well, the guy who stepped up to this massive challenge was a climatologist named Vladimir Köppen, and his solution was frankly brilliant. He developed a system that classifies every climate using just a simple code of letters. You can really think of him as the original climate code maker.
Okay, before we get into the code itself, we've got to be crystal clear on one thing, and this is super important. We're talking about climate, not weather. Weather is, what's happening outside your window right now. Climate is the average pattern over a really long time. We're talking at least 30 years. Here's a good way to think about it. Weather is the outfit you chose to wear today. Climate is your entire wardrobe. So, to crack Köppen's code, we're going to need the right tool for the job. And our main decoding tool is something called a climate graph. If you can understand this one simple visual, I promise the rest is a piece of cake.
And you know what? It's way simpler than it looks. See those blue bars? That's just the average rainfall, or precipitation, for each month. And that red line that goes across, that's the average temperature. That's literally it, just temperature and precipitation. These two factors are the foundation of Köppen's entire system. Amazing, right? All right, you ready? Let's get into the code itself. The most important piece of the puzzle is the first letter. This is the big one, the main key that sorts every single climate on Earth into one of 5 major groups.
Our first main group is A. A is for tropical climates. Go ahead and picture rainforests, jungles, that whole warm and wet vibe. The rules for an A climate are very specific. For one, they're found near the equator. But here's the real kicker. The average temperature of even the coldest month is still above 18 degrees Celsius, which is about 64 Fahrenheit. That means it is warm all year long. And, as you'd probably guess, those blue bars for rain on the climate graph are usually pretty high. We're talking a lot of precipitation.
Next up, we have the letter B. And B stands for dry climates. This is where you'll find the world's deserts and steppes. The defining feature here is simple, a lack of water. In a B climate, more water could potentially evaporate than actually falls as rain. So on a climate graph, those blue bars are going to be very, very low. Now, what's interesting is these areas can be hot or they can be cool, but they are always, always dry. Okay, let's tackle C and D climates together, because their key difference is so important. C stands for temperate climates, and they're often influenced by the sea. D is for continental climates, which are influenced by big land masses. Now, they both have warm summers, with the warmest month averaging over 10 degrees Celsius. But the real difference? It all comes down to winter. In a C climate, the coldest month stays above -3 degrees Celsius. In a D climate, it drops below -3. That one number is the magic dividing line.
And that brings us to our last main key, the letter E. This one's pretty straightforward, as you might guess. It stands for polar climates. The rule for E climates is dead simple. Here, the average temperature of even the warmest month of the year never gets above 10 degrees Celsius. It is just consistently cold, which is exactly why we find tundra and massive ice caps in these regions.
So there we have it, our 5 main groups, A, B, C, D, and E. But Köppen, of course, wanted more detail. So let's move on to the second letter and see how this builds a more specific picture, usually telling us about the pattern of precipitation.
For the A, C, and D climates, we add a lowercase letter. And here's a really cool trick to remember them because they come from German words. F comes from the word fehlt, which means lacks, so it lacks a dry season. It rains all year. S comes from sommertrocken, which literally means summer dry. And W comes from wintertrocken, meaning, you guessed it, winter dry. A super handy way to remember the pattern of rainfall.
Now, the B and E climates use an uppercase second letter. For B climates, we get another German clue. Capital W stands for Wüste, or desert. This is the driest of the dry. Capital S is for steppe, which is semi-arid, so still dry but with a bit more rain. For the polar E climates, T means tundra, where the warmest month is just barely above freezing, and F means frost, where it never gets above freezing. Think permafrost. And there's also H, which is a special one for highland or mountain climates.
Okay, so we've got the first letter, we've got the second letter, we have all the tools we need. So now, for the really fun part, let's put our new knowledge to the test and decode a real-world example. We're going to apply our new code-breaking skills to figure out the official Köppen classification for the Netherlands.
Let's walk through this step by step. First, let's look at temperature. The warmest month in the Netherlands is above 10 degrees, and the coldest month is above -3. So, based on our rules, what does that make it? A sea climate. Perfect. Okay, next up is precipitation. Thanks to being so close to the sea, there isn't really a dry season. It gets rain pretty consistently all year. So, which second letter means lacks a dry season? That's our lowercase f.
And there you have it. You combine the two, and the Netherlands is officially classified as a CF climate, a temperate climate with no dry season. See how those two little letters tell a whole story? That's the real power of the Köppen system.
Ultimately, this system isn't just for scientists. You now have the keys to decode the climate anywhere on Earth. So, I'll leave you with a question. What story do the letters tell about the place where you live? What does the climate code for your hometown reveal? Thanks for tuning in.